Good morning, all of you. Am I audible?
Yes, ma'am.
Okay. Okay. Screen is visible to you.
Yes, ma'am.
Okay. So good morning, all of you. Today we will start section second. So in that, unit number 5 is shear force and bending force. So please write down unit number 5, shear force and bending force. Shear force and bending force. Shear force and bending force. So first we will see syllabus and then we will discuss one by one. Okay. So syllabus, please write down syllabus of unit number 5. Analysis of analysis of analysis of
मॅम स्क्रीन दिसत नाही पुढची स्लाइड.
okay, please wait. Now it is visible.
Yes, ma'am.
Okay. So please write down syllabus. Analysis of statically determinate beams. Analysis of statically determinate beams. Analysis of statically determinate beams. In that, we have to learn following points. Shear force and bending moment diagrams. 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 For beams subjected to point load. For beams subjected to point load. Subjected to point load. For beams subjected to point load. In bracket, inclined load also. Okay, subjected to point load and in bracket, inclined load also. Then solve down. Uniformly distributed load. Uniformly distributed load. Uniformly distributed load. The next point is uniformly varying load. Uniformly varying load. Uniformly varying load and couples. Uniformly varying load and couples. Full stop. And last point is a relation between intensity of load, intensity of load, shear force and bending moment. Shear force and bending moment. Shear force and bending moment. Okay, so this is the syllabus. Okay, so unit number 5 is shear force and bending force. In that, we have to learn how to draw shear force diagram and bending moment diagram for statically determinate beams. Statically determinate beams. So in this unit, we will see only how to draw shear force and bending moment diagrams when various type of loads are applied. So in that, first point is point load, second one is uniformly distributed load, third one is uniformly varying load, couples. Okay, so suppose we have taken this beam and this load is applied. So this type of load is called as point load. Then second is, suppose this is the beam AB. On that beam this type of load is applied. So this is called as uniformly distributed load. And third one, that is uniformly varying load. So this load is called as uniformly varying load. Okay, after that we will see one by one in detail. Okay, then next is due to couples. Okay, so according to these various types, how to draw shear force and bending moment diagram. So this part we have to learn in this unit number 5. So before starting the unit, first we will see what is meant by statically determinate beams. Okay, and then we will start syllabus. Because of here, one word is there, statically determinate beams. Statically determinate beams. So first we will see what is meant by statically determinate, and then we will start actual syllabus. Okay. So there are two types of beams. First one is statically determinate beam. Statically determinate beam. Statically determinate beam. Statically determinate beam. And next one is indeterminate beam. Next one is indeterminate beam. Indeterminate beam. Indeterminate beam. Okay. So for this, there are three conditions. Okay, for this there are three conditions. First that is unstable. Okay, unstable beam. Second one is stable or statically determinate beam. Stable or statically determinate beam. And third one is indeterminate beam. Third one is indeterminate beam. So first, we will see what is meant by statically determinate beam. Okay. So I will write here definition. You can also write, and then we will see what is meant by statically determinate beam. Okay. So for that, I will share new screen and explain in detail. So please write down first point. Statically determinate beam. What is meant by statically determinate beam? Statically determinate statically determinate beam. So first we will write definition and then I will explain. Statically determinate beam. When number of unknown reactions, number of unknown reactions and movements, number of unknown reactions and movements equal to equal to number of equal to number of equation of statics, number of equation of statics, number of equation of statics, number of equation of statics. So when we say the beam is statically determinate beam, if number of unknown reactions and movements equal to number of equation of statics. So first we will see how many number of equations of statics. So there are three equations of statics. Okay, please remember this. There are three equation of statics. Equation of statics. There are three equation of statics. In that, first is summation Fh which is equal to 0. Second is summation Fv which is equal to 0. And third one, summation moment at any point which is equal to 0. So there are three static equations. Okay, three static equations. Now we will move towards number of unknown reactions and movements. So this number of unknown reactions and movements are depend on types of beams. Okay. So suppose I have taken this beam. Okay, I have taken this beam. Suppose this is A point, this is B point. Okay. So now you tell me in this beam, how many number of unknown reactions and moments? Anyone? How many number of unknown reactions and moments? Yes, from mechanics, you have to remember any point or not? Okay. So here, first one reaction is reaction at point A and reaction at point B. So these are the two reactions. So number of unknown reactions and movements are two. Okay. Should be less than or equal to. Okay. No, we have to check this number of reactions which is equal to number of static equations or not. And unknown equations are how many? Unknown equations are three. Unknown equations are three. So 2 is less than 3. So structure is unstable. Structure is unstable. Okay, this structure is unstable. Now we will see next point. Okay, now we will see next point. Suppose this is B and here one roller support is provided. Now you tell me for this particular beam, how many number of reactions are there? Anyone?
3.
Three. Which three?
हिंजच्या तिथं 2 आणि रोलरला 1.
Okay, good. So for hinge support, one vertical and one horizontal. So this is RA and this is RH. And roller support, for roller support, here one reaction. So now for this particular beam, number of unknown reactions and movements are 3. And how many number of equations of statics? 3. So 3 which is equal to 3. So this beam is stable, or this is also called as statically determinate beam. This is also called as statically determinate beam. Okay, this is called as statically determinate beam. Then we will see next example. Suppose this is. Now you tell me here how many reactions are there? Reactions and movements. Suppose this is A point and this is B point. Yes.
Three.
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 Okay, so here one vertical reaction, one horizontal, and one movement. So here number of unknown reactions and movements are 3, and number of equations of statics also 3. So 3 which is equal to 3. So this beam is also called as stable or determinate beam. Stable or determinate beam. Now I will draw next figure. So you can also tell me here. Now you tell me how many reactions are there? Yes. How many reactions?
6.
6. Good. So 3 for one support and 3 for second one support. Okay. So here RA, RH, and this is movement. Okay. So here also RB, this is RH, and this is also movement. So 3 for this fixed support and 3 also this fixed support. So 3 plus 3 which is equal to 6. So number of unknown reactions and movements are 6, and number of static equations are 3. So 6 should be greater than 3. So this structure is called as overstable structure. This structure is called as overstable structure. This structure is called as overstable or indeterminate structure. Indeterminate structure. Indeterminate structure. Got it? If number of unknown reactions and movements are equal to number of equation of statics, then we will say this structure is statically determinate structure. But if number of unknown reactions and movements should be greater than the number of equations of statics, this beam is called as indeterminate beam. Okay, got it? So please write down up to this point, then we will move towards next point.
हॅलो मॅम.
Yes.
हा मॅम, ते लास्टला जे डायग्राम दाखवले त्यात समजा सगळे फोर्सेसची मॅग्निट्यूड सेम असेल आणि सगळे झिरो येत असेल किंवा एकदम बॅलन्स असेल तर मग काय म्हणायचं?
मॅग्निट्यूड म्हणजे
म्हणजे समजा आता मुवमेंट पण सेम, म्हणजे मुवमेंट कॅन्सल होणार एकमेकांना आणि सगळे आर एच आणि आर ए सगळे सेम असेल तर वगैरे.
नाही, तसं नाही. तर स्ट्रक्चर हे स्टॅटिकली डिटर्मिनेट का इनडिटर्मिनेट, फक्त हे नंबर ऑफ अननोन रिएक्शन्स आणि इक्वेशन्स वर डिपेंड आहे. मॅग्निट्यूड वगैरे काय नाही घ्यायचं आपल्याला. ते फक्त आपल्याला काय कन्सिडर करायचे की हाऊ मेनी नंबर ऑफ अननोन रिएक्शन्स अँड मोमेंट्स.
ओके मॅम.
Okay, your rating is over.
Yes, ma'am.
No, ma'am.
Okay, okay. Let me know after your rating is over.
Ma'am, 2 मिनिट थांबा.
Okay, okay. Okay, from this slide, just you have to remember that if number of unknown reactions and moments which is equal to number of equations of statics, then this beam is determinate beam. Okay, so if number of unknown reactions should be less than or should be greater than number of equation of statics, then this beam is indeterminate beams. And how many number of equations of statics? There are 3 equations of statics. Summation horizontal forces which is equal to 0, summation vertical forces which is equal to 0, and summation movement which is equal to 0. Okay, now your writing is over or not?
Yes, ma'am.
Okay, so we will take another example. Yes, please repeat once again, you are not audible clearly. Yes, anybody having doubt?
हॅलो मॅम, मगाशी मी जो क्वेश्चन विचारलेला ना, ते समजा बॅलन्स असेल तर ते कॅन्सल होणार रिॲक्शन. मग
नाही.
त्या consider करायच्या का आपण? समजा आता आपल्याला इक्वेशन स्टॅटिकली डिटर्मिनेट आहे का नाही हे बघायचं, मग त्या रिॲक्शन कन्सिडर करायच्या का?
बघा, आपल्याला काय करायचंय की नंबर ऑफ अननोन फोर्सेस, सॉरी, रिएक्शन्स अँड मुवमेंट्स, फक्त नंबर्स किती आहेत ते फाइंड आउट करायचंय. त्याचे मॅग्निट्यूड किती असेल आणि ते मॅग्निट्यूड जर सेम असतील तर ते कॅन्सल होतील का, त्याचा विचार आपल्याला करायचा नाहीये. तर एखादा आपण जर बीम घेतला तर त्या बीम वरती नंबर ऑफ अननोन रिएक्शन्स किती आहेत ते फक्त बघायचंय. त्या नंबर ऑफ अननोन रिएक्शन्स वरती डिपेंड असणार आहे की स्ट्रक्चर हे स्टॅटिकली डिटर्मिनेट आहे की इनडिटर्मिनेट आहे. आता बघा, हा पर्टिक्युलर बीम घेतला तर आता समजा इथे 10 किलो न्यूटन लोड आहे आणि इथे पण 10 किलो न्यूटन लोड आहे, असंच म्हणायचं ना तुम्हाला?
हा, येस मॅम.
हा, तर इथे किती झाले तुमचे हे अननोन रिएक्शन्स? दिस इज फर्स्ट वन अननोन रिएक्शन अँड दिस इज सेकंड वन. हिअर मॅग्निट्यूड डझंट मॅटर, जस्ट यू हॅव टू count how many number of unknown reactions and movements. Now, okay. So we will take one real life example so you have to easily understood. Suppose this is a vegetable table. बघा, ही काय केली, ही आपली भाजीची गाडी आहे. आणि याला पुश करताना काय करतो, हा आपण इनक्लाइन लोड अप्लाय करतो. ठीक आहे. तर मला सांगा, आता हे स्ट्रक्चर स्टेबल असेल का अनस्टेबल असेल?
अनस्टेबल.
अनस्टेबल बिकॉज ऑफ इथे काय असणार आहे, आपला हा एक वन मॅन असेल आणि तो काय करतो, इथे इनक्लाइन फोर्स अप्लाय करतोय. तर त्या इनक्लाइन फोर्समुळे ही भाजीची गाडी काय होणार आहे, तुमची मूव्ह होणार आहे. तर ती कुठल्या डायरेक्शनला मूव्ह होणार आहे? हॉरिझॉन्टल डायरेक्शनला मूव्ह होणार आहे. ओके. सो हिअर नंबर ऑफ अननोन्स आर 2. These 2 are unknowns and number of static equations are 3. So 2 should be less than 3. So this structure is unstable. This structure is unstable. तर आता मला ह्या स्ट्रक्चरला स्टेबल बनवायचंय. तर स्टेबल बनवण्यासाठी काय करावं लागेल? कोण सांगते मला? याला स्टेबल बनवण्यासाठी काय केलं म्हणजे ते स्ट्रक्चर स्टेबल बनेल? Anyone have idea?
अपोजिंग फोर्स अप्लाय.
अपोजिट फोर्स म्हणजे ही गाडी, बघा, अपोजिट फोर्स म्हणजे काय करावं लागेल, ही गाडी काय करते, आपली हॉरिझॉन्टल डायरेक्शनला मूव्ह करते. ठीक आहे. जर मी त्याला इथं जर एक ऑब्स्ट्रक्शन दिलं, इथं जर काय केलं, त्याला एक ऑब्स्ट्रक्शन दिलं, तर काय होणार आहे, त्याची मुवमेंट स्टॉप होणार आहे. आणि ऑटोमॅटिक इथं नंबर ऑफ रिएक्शन्स किती होतील? मग इथं ऑब्स्ट्रक्शन असल्यामुळे काय होणार आहे, इकडून एक हॉरिझॉन्टल फोर्स अप्लाय होणार आहे. ऑलरेडी इथे एक व्हर्टिकल आहे, इथे एक व्हर्टिकल आहे. सो नंबर ऑफ रिएक्शन्स 3 and number of equations 3. So 3 which is equal to 3. So this structure is called as stable structure. Now your doubt is clear?
Yes, ma'am.
We take another example. Okay. Suppose I have put obstruction for these 2 wheels. Obstructions for these 2 wheels. So whenever I will put obstructions for these 2 wheels, at that time automatically there are 4 reactions. This horizontal one, this horizontal, this vertical and this vertical. So there are 4 reactions and unknown equations are 3. So these 4 should be greater than 3. So structure is overstable. Structure is overstable. जर मी या इथे जो काही आपण ऑब्स्ट्रक्शन प्रोव्हाइड केलेलं आहे, हे ऑब्स्ट्रक्शन जर रिमूव्ह केलं तरी सुद्धा आपलं स्ट्रक्चर काय येऊ शकतं, स्टेबल येऊ शकतं. सो अनस्टेबल, स्टेबल अँड ओव्हरस्टेबल. ना आता तुमचा डाऊट क्लिअर झालेला आहे की स्ट्रक्चर हे डिटर्मिनेट आहे की इनडिटर्मिनेट आहे. इफ नंबर ऑफ अननोन रिएक्शन्स अँड मुवमेंट्स, नंबर ऑफ अननोन रिएक्शन्स अँड मुवमेंट्स is which is equal to number of equilibrium or number of equations of static equations, then this structure is determinate structure. Okay, this structure is called as determinate structure. Okay, so this is the real life example. From this example your doubt will be clear. Now आता आपण असं बघूया की number of equations. Okay, number of static equations, number of static equations. ओके, नंबर ऑफ स्टॅटिक इक्वेशन आपण काय म्हणतोय, 3च आहेत. तर ती 3च का आहे तो, कशामुळे ती 3च असतील हे आपण बघूया. सपोज I have taken this is particle or ball and I thrown this ball into air. Okay, whenever I will throw this ball in air at that time, so it will be rotate in 3 directions. Okay, in 3 directions. Or first we will see what is meant by degree of freedom. Okay, already you have studied it in first year. Anyone have remember degree of freedom? Degree of freedom. आठवते का कोणाला? So degree of freedom means number of independent coordinates required to represent the motion of the body complete. म्हणजे मी हा जो काही बॉल आहे हा हवेत फेकल्यानंतर त्याची मोशन कंप्लीट होण्यासाठी किंवा तो बॉल हवेत थ्रोन केल्यानंतर किती डायरेक्शनला फिरतोय ते म्हणजे काय असणार तुमचं डिग्री ऑफ फ्रीडम. ते काय असेल तुमचं डिग्री ऑफ फ्रीडम. सो देर आर 3 translation motions. Suppose we have taken 3D, we have taken 3D particle. Okay, 3D particle. Then this 3D particle, there are 3 degree of freedoms or 3 particle motions. Particle motions. 3 motions. Okay, so there are 3 motions. There are 3 motions. Okay, I will draw figure here. Suppose we have taken 3D, then these are the 3 motions. Suppose this is Z axis, this is Y, and this is X axis. So these are the 3 motions. Also, these 3 motions, degree of freedom is required. Okay, so rotation is required here. So rotation along Z, rotation along Y, and rotation along X. So for 3D particle, 3 motions and 3 rotations. 3 motions and 3 rotations. So number of degree of freedom, degree of freedom, degree of freedom for 3D particle, for 3D particle which is equal to how much? 3D particle which is equal to 3 motions and 3 rotations. So number of degree of freedom for 3D particle is 6. Okay, so instead of this I have taken 2D particle. Okay, 2D. So 2D like our notebook page. 2D is like our notebook page. So this is the 2D, and in that there are only 2 axes. Okay, so this is X axis and this is Y axis. Okay, so these are the 2 axes, but at that time one movement will be generated along this perpendicular axis, and this movement is called as Z. This is called as mz. This is called as mz. So for 2D particle there are 3 equations. Summation force along x axis which is equal to 0, summation force along y axis which is equal to 0, and due to this one movement will be generated. So summation movement which is equal to 0. That's why number of unknown equations of statics for 2D plane are 3. Okay, and suppose we have taken 3D, so at that time number of equations are 6. Okay, got it? So these 3 equations are coming from degree of freedoms. So whenever we will take 2D particle, in that 2D particle, there are 2 axes, x axis and y axis. But due to this, one movement is generated for this perpendicular axis, and this movement is noted by mz. So there are 3 equations: summation of horizontal forces, summation of vertical forces, and summation of movement which is equal to 0. Therefore, for 2D particle, number of equation of statics which is equal to 3. Okay, so please this thing also you remember. Now your doubt is clear regarding degree of structure is determinate or indeterminate. Now we will move towards our syllabus. Okay, so before starting syllabus, first we will see types of beams, types of loads, and then we will start syllabus. Okay, so when we say structure is determinate, please recall. Yes, when we say structure is determinate. Yes,
When
anyone?
are reaction and moments equal to number of equation of
Number of unknown reactions and movements, which is equal to number of
equation of
equations of statics. So
static.
structure is determinate structure, or beam is determinate beam. Okay. So next point, types of beams. Please write down next point, types of beams. Okay. Before writing, you tell me this cantilever beam. My screen is visible?
Yes,
Okay. So this cantilever beam is stable or unstable? This cantilever beam?
stable.
Stable.
Why?
Stable.
How you have?
3 reactions equal to 3
Three
equations.
Okay.
present.
So for this cantilever, one vertical, one horizontal, and one movement is there. So number of reactions 3, which is equal to number of equations 3. So this beam is statically determinate beam. Now you tell me, for this simply supported beam, how many unknown reactions and movements are there?
3.
3. So 2 for
3.
hinge support and 1 for roller support. So here 2 and here 1. So number of unknown reactions and movements 3, and number of static equations are 3. So 3, which is equal to 3. So this structure is also statically determinate or stable structure. Now you tell me, for this overhanging.
Unstable.
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 Unstable. Okay, unstable. So this structure is stable as well as unstable. If we have applied here one exactly perpendicular load, then this structure is stable. If we have applied inclined load, okay, instead of this vertical load, suppose you have applied this inclined load, at that time this structure is unstable because of this move towards this horizontal direction. Okay, so this structure is unstable. But if we put exactly perpendicular load, then this structure is stable. So this overhanging structure is stable as well as unstable. Okay, then now you tell me, for this continuous, how many number of reactions and movements?
Five.
Overstable.
Yeah, overstable, but how many number of reactions and movements?
5.
5.
5.
So 2 for this hinge support, 1 for this roller, 1 for this roller, and 1 for this roller. So there are 5 number of unknown reactions and movements, and equations of statics are 3. So this 5 should be greater than 3. So this structure is overstable. This structure is overstable or indeterminate beam. Okay. So for getting stable structure, we have removed 2 supports. Okay, suppose we remove this support and this support, then and then this structure is stable. जर आपण हे 2 सपोर्ट जरी काढले तरी हे स्ट्रक्चर काय होऊ शकतं बघा, तुमचं स्टेबल होऊ शकतं, बिकॉज ऑफ हिअर नंबर ऑफ रिएक्शन्स are greater than number of equations of statics. Okay, so this structure is overstable. Now you tell me, for this fixed ended beam.
Overstable.
Yes, overstable, but number of unknown reactions and movements
6.
6. For fixed support, there are 3 number of reactions and movements. One is vertical, then horizontal and movement. So for this first fixed support, 3 reactions and movements, and for this second fixed support, there are 3. So 3 plus 3, 6 should be greater than 3. So this structure is overstable or indeterminate structure. Okay, this structure is overstable or indeterminate structure. If I remove this fixed support, then also this structure is stable because of this structure is overstable by 3 reactions. Suppose I have removed 3 reactions, then also the structure is stable. Now you tell me for this
Overstable.
over stable, because of for this fixed support there are 3 reactions and for this roller 1. So number of unknown reactions and movements are 4 and number of static of equations are 3. So 4 should be greater than 3. This structure is overstable or indeterminate beam. Now your doubt is clear. So there are 6 types of beams. First one is cantilever. When we say the beam is cantilever, one end is fixed and another end is free. So this beam is called as cantilever beam. Okay. So simply supported means if 2 hinge support are provided. So this is called as simply supported. One hinge and one roller is provided. So this is also called as simply supported beam. Then overhanging means support. Okay, support is not provided at the end. Okay, so you observe here from this support to this part is hanging. त्याला काही support आहे का? नाहीये. So if support is not provided at the end, so this is beam is called as overhanging beam. So next type is continuous. So why this beam is called as continuous? If number of supports are more than 2. Number of supports are more than 2, then this beam is called as continuous beam. Now you observe this fixed ended beam or fixed beam. Why this beam is called as fixed beam? Because of both supports are fixed. So this is called as fixed ended beam. And this is called as cantilever, or also this is called as propped cantilever. Propped cantilever. Propped cantilever. So one end is fixed and for other end, one roller or hinge is provided. So this beam is called as propped cantilever beam. So there are 6 types of beams. Okay. So one MCQ will be asked types of beams. So please remember, if one end is fixed and other end is free, cantilever. Okay. So 2 supports are provided at the end. This is simply supported. If support is not provided at end, so this is called as overhanging. If number of supports are more than 2, this beam is called as continuous beam. If beam is fixed at both ends, this is called as fixed beam or fixed ended beam. And cantilever or propped cantilever means one end is fixed and on another end some roller or hinge support is provided. So this is called as propped cantilever beam. So all of you please draw these figures. Then we will move towards types of loads. So please draw fast and let me know after your drawing is over. Okay, your writing is over.
Yes, ma'am.
Okay, please wait. 1 minute. Okay, my screen is visible. Yes.
Yes, ma'am.
Okay. So please write down next point, types of loads. Next point is types of loads. Types of loads. Types of loads. So you observe here, there are 4 types of loads. So first is concentrated load or point load. Concentrated load or point load. Suppose I have taken this beam. Okay, I have taken this beam and I have applied this load. So this load is applied particularly at a point. Particularly at a point. So this load is called as point load or concentrated load. Okay. Then second is uniformly varying load. So you observe here, this load is uniformly vary from A point to B point. Okay, so this load is called as uniformly varying load. After that, next third one is uniformly distributed load. So suppose we have taken this beam and I have applied the load likewise. Load likewise means full load is applied here. Full load from A support to B support. From A support to B support, I have applied load. So uniformly applied. So this load is called as uniformly distributed load. Okay. And next one is movement or local concentrated movement. So you observe here, this is a movement. So for that, I will give one example to you. Suppose this is a beam. Suppose this is a structure, and on that structure we have constructed a tower. We have constructed a tower. So this on this structure, wind force will be applied. On this structure, wind force will be applied. So this force, and this wind force is applied at the height. Okay, this wind force is applied at the height. So force into this height, it will automatically create movement. It will automatically creates movement. So movement which is equal to force into height. That is force into perpendicular distance. So this is called as movement. So first one is point load or concentrated load. Point load or concentrated load. Suppose this is a beam, and on that beam we are applied load at particular point. Okay, so this load is called as concentrated or point load. After that, uniformly varying. So you observe here, this load is vary from A point to B point. Okay, so this is called as UVL or uniformly varying load. And uniformly distributed load means this is beam, and on that beam load is applied throughout the beam uniformly. So this is called as uniformly distributed load. And movement means, suppose this is a structure and on that we have constructed one tower. So on this tower, wind force will be generated. Wind force will be applied. So due to this force, movement will be generated. Because of this force is applied at height. So force into perpendicular distance, this is called as movement. Okay, so these are the types of loads. So please write down these types of loads and draw figures and let me know after your drawing is over. So we will move towards next point.
मॅम ते लिहिलेलं क्लिअर दिसत नाही.
Okay. If your writing is over, shall I move towards next point? Yes.
Yes, ma'am.
Okay. So these up till now we have studied as basic concepts. Now we will solve some numericals, how to calculate reactions, and then we will start shear force and bending moment. Okay. So now we will solve numericals on calculation of reactions. Okay. So please write down first example. Find reactions. Find reactions for figure given below. Figure given below. Given below. So I will draw figure here. You can also draw, and then we will solve problem. Okay. So this is AB beam given. On that beam, one point load and one uniformly distributed load is applied. So point load is applied at 2 meter from a side and remaining is 4 meters. So uniformly distributed load is applied on 6 meter span. So for this figure, we have to find out reactions. We have to find out reactions. So now we will solve this problem. So whenever we will find out reactions, at that time you have to remember upward force we will consider positive, downward force we will consider negative, clockwise movement we will consider positive, and anti-clockwise movement we will consider negative. So these sign conventions are useful for finding out reactions only. Okay, so for finding out reactions only. So first we will apply summation fh which is equal to 0, summation fh which is equal to 0, or summation fp which is equal to 0, summation vertical forces which is equal to 0. So whenever we will apply the summation vertical forces which is equal to 0 equation, please remember upward force positive, downward force negative. Upward force positive, downward force negative. Okay. So now we will find. So suppose this is RA and this is RB. So this RA and RB going upward, so we will consider positive. So RA plus RB. Then next force is this 80 kilonewton force, and this 80 kilonewton force going downward direction, so minus 80. Then this 20 kilonewton per meter force again pushes downward, so this is also minus. But you observe this is uniformly distributed load, so we have to multiply by length for this load. So 20 into 6 which is equal to 0. So RA plus RB which is equal to, now we will shift this 80 and minus 20 into 6 to right side. So 80 plus 20 into 6, 120. Okay. So RA plus RB which is equal to how much?
200.
200 kilonewton. So this is our equation 1. Okay. Then next step we will apply summation moment at a point which is equal to 0. Second condition is summation moment at any point. Either you take moment at a point or b point. So we will take at a point. Summation moment at a which is equal to 0. So whenever we will find out moment, okay, for these reactions only. So clockwise movement positive and anti-clockwise movement negative. So you observe here this RB creates anti-clockwise movement towards a point. So we will consider plus or minus. This RB creates anti-clockwise movement towards a point. So this movement is positive or negative?
Negative.
Negative.
Minus. Movement means first you clear force into perpendicular distance. So this is called as movement. So this RB is force and perpendicular distance is this 6 meter. So minus RB into 6. So this point is over. Now we will move towards this uniformly distributed load. Okay. So this uniformly distributed load creates clockwise movement towards a point. So we will take positive. So plus 20 into 6 into, it will act at CG. So 6 by 2. Okay. Then we will move towards next force that is 80 kilonewton. So this 80 kilonewton again creates clockwise movement. So we will take positive. So 80 into, now you tell me perpendicular distance for this 80 kilonewton force is how much? Okay, 80 into 2. Now you observe this. Here RA force is there at a point, but perpendicular distance for this RA which is equal to how much? Anyone? Suppose we have to consider this RA point. Okay. So Force is there, but perpendicular distance is how much?
0.
0.
0. That's why here we will not consider. Okay, so which is equal to 0. Now we will shift this minus 6 RB to right side. So what is remaining? 20 into 6 into 6 by 2. So 2 ones are 2, 2 threes are 6. So you calculate 20 into 6 into 3 plus 80 into 2. So we will shift this minus RB into 6 to right side. So 20 into 6 into 3 plus 80 into 2 is 160, which is equal to 6 RB. So 20 into 6 into 3.
520.
3.
520.
Okay, addition of this all, na?
Yes.
520, which is equal to 6 RB. So therefore, RB, which is equal to 520 divided by 6. So therefore, RB, which is equal to how much?
86.66.
80.
86.66.
I think you have done some mistake.
86.66.
86.66. Please wait. Huh? Huh, 80. Yes. RB, which is equal to how much?
86.66.
86.66
66.
kilonewton. Okay. So once we got RB, then we will put this value of RB in equation 1. So put RB in equation 1. RB in equation 1. So what is our equation 1? RA plus RB, which is equal to 200. So therefore, RA plus 86.66, which is equal to 200. Therefore, RA, which is equal to 200 minus 86.66, and therefore finally RA, which is equal to
3.34.
1, 3,
113.34.
3, 4.
kilonewton. So this is the reaction at A support. So in that way, we have to calculate reactions. Okay. So if anybody having doubt, please ask me, because of this is the basic step for starting shear force and bending moment diagram. Anybody having doubt?
No, ma'am.
Okay. So please write down. We will take next example. Please write down fast. Okay, so we will take next example. Find reactions. Find reactions for given beam below. So here, draw diagram. Suppose this is A point and this is B point. So here, one concentrated load is applied and the intensity of concentrated load is 50 kilonewton, and the intensity of this uniformly varying load is 60 kilonewton. Uniformly varying load is 60 kilonewton. So here AB beam is given. On that beam, one uniformly varying load is applied and the intensity of varying load is 60 kilonewton, and one point load is applied and the intensity of point load is 50 kilonewton. Okay, so point load is applied 2 meter from A point. Okay, so for this, we have to find out reactions. So first step, we will apply summation FV equation. Okay. So our first equation is summation vertical forces, which is equal to 0. So in that we will take addition of all vertical forces. So whenever we will consider vertical forces, upward force will be positive and downward force will be negative. So these RA and RB, these RA and RB going upward direction. So RA plus RB, RA plus RB. This 50 kilonewton force going downward direction. So minus 50. Now this uniformly varying load. So uniformly varying load means area of this particular figure. Area of this particular figure. So this is triangular portion, and area of triangular portion is 1/2 into base into height. So base is 6 meter. So 1/2 into 6 into height is 60 kilonewton. So height is 60, which is equal to 0. I have taken here minus sign because of this force is going downward direction. And intensity of this uniformly varying load, how to calculate? So uniformly varying load, we have to consider area of this particular figure. So the shape of this figure is triangle and the area of triangle is 1/2 base into height. So base means span and height means here intensity of load is given 60. Okay. Therefore, RA plus RB, which is equal to, we will shift this to right side, 50 plus 1/2 into 6 into 60. So you calculate RA plus RB, which is equal to how much?
230. 230.
230 kilonewton. So this is our equation 1. Then we will apply movement equation. Okay, we will apply movement equation, that is summation movement at any point which is equal to 0. So we will apply movement at A point. We will consider movement at A point. So second is summation movement at A, which is equal to 0. Okay. So again this RB creates anti-clockwise movement. So this will be considered minus. So minus RB into perpendicular distance is 6. Okay, perpendicular distance is 6. Then this 60 kilonewton uniformly varying load creates clockwise movement. So we will consider positive. So first we will convert this into load. So how to convert? 1/2 into base into height. So this is the load and perpendicular distance. So whenever we will take distance from smaller side, so 2/3, and we will consider from this larger side, so 1/3. So we will consider from this A point. So CG of this triangle is 2/3 into base, and base is 6. So this is the force, this is force, and this is perpendicular distance. Next force is 50 kilonewton. This creates clockwise movement towards A point. So plus 50 into perpendicular distance is 2. Okay, which is equal to 0. Here I have not taken this RA force because of this RA perpendicular distance is 0. So automatically we get value 0. That's why I have neglected. So we will shift this minus RB into 6 to right side. So 1/2 into 6 into 60. Okay, this is the force, and perpendicular distance is 2/3 into 6 plus 50 into 2 is 100, which is equal to 6 RB. So you calculate this and tell me what is the value of this. Yes. हा रोहन सांगा किती येते व्हॅल्यू. रोहन वनसाळे.
Ma'am, 820.
Yes.
820.
20.
Please repeat once again.
820. 820.
820.
Yes, ma'am.
820, which is equal to 6 RB. So therefore RB, which is equal to 820 divided by 6, and therefore RB, which is equal to how much? 136.67 or 66 kilonewton. Once you got RB value, then you put this value of RB in equation 1. So put RB in equation 1. Equation 1. So what is our equation 1? RA plus RB, which is equal to 230. So RA plus the value of RB is 136.67, which is equal to 230. Therefore RA, which is equal to 230 minus 136.67, therefore RA, which is equal to how much?
$93.33.
93.33 kilonewton. So this is the value of RA. So please remember, if uniformly varying load is given, so you have to convert load. So how to convert? The load means area of this particular figure. Okay, just you have to remember that, because of whenever we will calculate shear force and bending moment, at that time this RA and RB is most important. That's why I have taken this example. So please write down fast. We will take next example.
Over, ma'am.
No, ma'am.
मॅम 2 मिनिट.
Okay, so please write down next example. Find reactions. Find reactions for beam given below. Beam given below. So I will draw figure. You can also draw. Then we will solve. Okay, so this is AB beam given. In that one movement is applied and one uniformly distributed load is applied. So for this particular figure, we have to find out reactions. Okay, so as per our regular procedure, first we will apply summation vertical forces which is equal to 0. So now you tell me how many vertical forces are there? Yes. Huh? Yes. RA plus RB. Then next force is this uniformly distributed load. So this uniformly distributed load is acting downward direction. So minus 30 into 9. Now you tell me this 10 kilonewton meter force we will consider in the summation FP or not?
Not.
Not. Because of this is the movement. already movement is given. That's why this movement we will not consider in vertical forces. Okay. So here if point load is given, then we will consider. But here movement is given. That's why we will not consider this movement. So which is equal to 0. So RA plus RB, which is equal to 30 into 9 is 270. 270 kilonewton. So this is our equation first. Then we will apply equation second. Summation moment at A, which is equal to 0. Summation moment at A, which is equal to 0. So this RB force creates anti-clockwise movement. So minus RB into 9. Then this 30 kilonewton force creates clockwise movement. So plus 30 into 6. So this is load 30 into 9 meter. 30 into 9. And it will act as siege of this span. So 9 by 2. Okay, 9 by 2. And now this third, this is movement. So this is again clockwise. So plus 10 into, now I will multiply by this perpendicular distance for this 10 kilonewton or not. इथे perpendicular distance ni multiply करायची गरज आहे का? नाहीये, because of already movement is given. So movement means force into perpendicular distance. So if movement is given at that time, take as it is whenever you are calculate summation movement at any point. So which is equal to 0. Now we will shift this minus 9 RB to right side and then we will continue. So according to this equation is 30 into 9 into 9 by 2 plus 10, which is equal to 9 RB. Okay. So 30 into 9 by 2 plus 10, which is equal to how much? Yes. Calculate and tell me what is the value of this. अक्षय घाडगे, विक्रम जगताप, सनी कचरे, Ganesh Kadlaskar, Vivek Kale. What is the answer? 30 into 9 by 2 plus 10.
25.
1225.
Please repeat once again.
1225. 1225.
1225, which is equal to 9 RB. Therefore, RB, which is equal to 1225 divided by 9. So RB, which is equal to
136.11. 36.11.
1 kilonewton. Then we will put this value in equation 1. So put RB in equation 1. So what is our equation 1? RA plus RB, which is equal to 270. So RA plus 136.11, which is equal to 270. Therefore, RA, which is equal to 270 minus 136.11. So RA, which is equal to
133.89.
133.89 kilonewton. So if movement is given at that time, you have to find out reactions likewise. So please write down. We will take next example. Okay, so today we will stop here. Remaining problems we will continue in next lecture. Okay. Please wait.
Over, ma'am.
Okay, so today we will stop here. Remaining problems we will continue in next lecture. Okay, so thank you for attending lecture.